Yes, students, let us understand formation of simplest molecular ion where only one electron is there, that is H2 plus, and little higher molecule which has two electrons, that is H2, by wave mechanical approach. What is wave? Generally, when we consider wave, then we understand sinusoidal wave, sine wave. How sine function varies? Sine 0, 0. Sine 90 means pi by 2, maximum 1. Sine 180 means pi, it is 0. Sine 270 means 3 pi by 2, minus 1, it's a minimum. And sine 360, 0. So such curve, that is our wave that we understand. Wave has two phases, two signs, two wave functions we say. This one positive wave function, positive phase, and other negative wave function. Means these are like two sides of coin. If I toss a coin, then two possibilities are there. I will get head or I will get tail. So if I take any wave, then one portion will be positive, other portion will be negative. But wait, observe this wave clearly. It's a start. So amplitude means existence is 0. Slowly existence improves, amplitude improves. I'm talking about wave function. Then amplitude decreases, and at pi amplitude becomes 0. Amplitude 0 means existence is not there. Wave doesn't exist at this position. Again existence, but sign is different. And at last wave ends. Whatever this region is there, this is a zero wave region. This is a node region. This node region you will understand in case of p orbital more clearly. If I consider one of the p orbital in this way, this is the positive lobe of that p orbital. Then we say this is a negative lobe. Why do we say? Because here whatever the wave is there, if it is a positive, while moving from this position to other position, in between there comes possibility of not existence of electron. That's our nodal point, or this is a nodal plane. Possibility of not existence means 0 amplitude. And here again possibility, but negative phase. So while moving from positive phase to negative phase, one node point has to come. If that node point is not there, then for example s orbital, which is spherically symmetric. If I start from nucleus, then till s orbital exists, you will find throughout electrons are there. You will find there is a no gap. You will find there is a no node. There is a no node means it can be either completely positive or it can be completely negative. So while representing that s orbital, I can say it is plus or minus, as like tossing a coin, head or tail. It is about the wave of one orbital. But while formation of molecular orbitals, such atomic orbitals wave we combine, and for combination we follow one principle. Which principle do we follow for combination? LCAO, linear combination of atomic orbitals. Wave of one atomic orbital and wave of other atomic orbital, they will combine. Now how do they combine that? Let us see. If it is a positive phase and other also positive phase, positive in wave mechanics there is attraction. When this positive come closer, it is an atomic state, atomic orbital. So in atomic orbital, what are you finding? Here is a nucleus. So as I go away from the nucleus, 0 probability of finding or 0 amplitude. Also here 0 amplitude. This is an atomic orbital. Similarly, other atomic orbital. These two will come closer during formation of molecule, during constructive interference. They are not just touching. No, they are overlapping. Yes. Now just see. Here is a nucleus. As I go to, from your point of view, right side of the nucleus, I will find Nowhere there chance electrons are not there. Electron amplitude is 0. Probability of finding electron is 0. Between two nuclei, we are finding more electron cloud. That's a construction. That's a constructive interference. Existence of electron between nuclei increases attraction. Because of that, in atomic orbital, whatever the happiness electron was with, more than that happiness electron gets due to constructive interference. Happiness means stability. Stability means decrease in energy. Therefore, due to constructive interference, we say resultant constructive molecular orbital. The orbital which is resulted due to addition of wave function, positive, positive, negative, negative, will be of low energy. Therefore, we represent 1s orbital of hydrogen, 1s orbital of other hydrogen, and here bonding molecular orbital. What about anti-bonding molecular orbital? Wave functions which combine, they remain opposite. Positive, negative, negative, positive come together, come closer. Positive wave function of one hydrogen you consider, and negative wave function. When they come closer, don't think only they are touching. They will interact, and due to that interaction, they will cancel each other. One region where, means you are finding the region between two nuclei where electron amplitude is 0, electrons are not existing, gap is there. If electrons are not existing between the nuclei, then nuclei will quarrel, they will repel each other. So that system, that's a molecular orbital system, will be with high energy. If an electron enters there in that orbital, then between two nuclei, electron will not work. Electron will not help for bonding. Contrary, electron will oppose for bonding. Therefore, we say it is anti-bonding molecular orbital. Now let us see H2 plus formation. H2 plus means I am considering left side atomic orbital of hydrogen. That's a 1s orbital. It has one electron. Other, I want to consider H plus means simple proton. But it's a theoretical approach. For that single proton also, possible energetics will be there. Possible energy levels will be there. That's a 1s level for that proton. It has no electron. But here electron is there. In this hydrogen atom, electron is there, and here electron is not there. But when molecular orbital forms, then they forget their individual property. It becomes combined property. That one electron enters in bonding molecular orbital, lower energy orbital. Between two nuclei, electron cloud exists. More electron cloud will be experienced. That's our constructive interference. Here hydrogen 1s orbital was with only one electron, and H plus was with no electron. When electron enters in a bonding orbital, previously H plus also experiences electron cloud. Original 1s orbital where one electron is there, that also experiences electron cloud. So possibility of existence of electron increases between the nuclei. That's a constructive interference. Electron is only one, but relative to the atomic orbital of hydrogen, in bonding molecular orbital, more electron cloud is experienced, more electron amplitude is experienced, more electron density is experienced. That is only one, but electron cloud model we are considering. So electron cloud between nucleus will be more compared to electron cloud which was there in atomic orbital. And because of that, energy of bonding orbital decreases, and entry of electron in bonding orbital helps for attraction, helps for bonding. Therefore, we label that orbital as bonding molecular orbital. On the other hand, if you consider anti-bonding molecular orbital, which is resulted due to the destructive interference of positive phase and negative phase. When they come closer, in between nuclei, electrons are not there. So two nuclei are there. In between you are finding gap, you are finding nodal plane where electrons are not existing. In such cases, if an electron enters, then will it help for bonding? No. Contrary, it will oppose for bonding. Therefore, we say it's anti-bonding molecular orbital. And energy of anti-bonding molecular orbital relative to atomic orbitals will be higher. So, in case of H2 plus, bonding molecular orbital sigma 1s will be with one electron. That one electron is enough to bring the attraction, equivalent to bond order 0.5. What about H2? Both hydrogen atoms are with one electron. They are with their own electron cloud, electron density. But when constructive interference occurs, electron density increases. Where electron was not there, there also increase. And where electrons are there, then also it increases. Anyhow, in bonding orbital, electron density between two nuclei increases. See here, constructive interference if it occurs, then these two nuclei by thumb which I am representing, they will fill in between. There is no gap. Electrons are always there. Suppose if I consider the mean distance here, then there also electron cloud is there. Considerable electron cloud is there. That's a constructive interference. That's an attractive interference. That's an additive interference. That's a bonding orbital formation. And what is the capacity of this orbital? To accommodate two electrons. So two electrons will enter in those bonding orbitals. Anti-bonding orbital will be there. Energetically will be there. But electron will not enter because only two electrons we do have. But suppose if we add electron, if we get 3 electron system and the same orbitals are involved, or 4 electron system and the same orbitals are involved, then electron will enter in anti-bonding molecular orbital. Here we are following Boole principle. Electron filling takes place from low energy orbital to high energy orbital. Hund's law of maximum multiplicity. Electron pairing will not occur till all orbitals of same energy levels are completely half-filled. And Pauli's exclusion principle. In orbital, electrons will be in paired fashion. So whatever the electrons are there in the bonding orbital, they will be in paired fashion. If I consider one spin is half, other spin will be the minus half. So is the constructive interference and destructive interference clear? Formation of bonding molecular orbital and anti-bonding molecular orbital clear? The wave approach the crust, that's a positive phase. Wave approach the trough, that's a negative phase. And combination of positive and negative phase forms the wave. But for 1s orbital, there is only positive either or only negative. Concept clear? Now students, I give you homework. Just you have to answer. Positive phase, what will be there as per molecular orbital theory? Attraction or repulsion? And second question, in bonding molecular orbital, electron cloud between nuclei is more or less? Answer these questions in the comment box. I am waiting for your answers. I hope wave approach is clear to you. Pictorially, I discussed in the one video, LCAO part 1. Graphically, I explained that. Now, it is better to explain by action. Therefore, I prepared this video. So, quantum mechanical approach through LCAO to describe the molecular orbitals of H2 and H2 plus is clear to us. You might have understood how the energy level or energetics changes and contribution of those various orbitals resulted molecular orbitals also changes. So let us discuss additional molecules in order to improve our concept of application of LCAO method to result molecular orbitals to explain bond order and magnetic properties from next part.